Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study what is the torque transmitted by a hollow circular shaft. So, the Bloom's taxonomy level related to this topic is apply level, and the course outcome is related to course outcome number 6. Now, we are going to solve some of the problems and also in this, we are going to solve some of the problems of we have to calculate the torque transmitted by a solid shaft also. So in this problem, a solid shaft of 150 millimeter diameter is used to transmit a torque. The diameter of the shaft is 150 millimeters. Find the maximum torque transmitted by the shaft. Find the maximum torque. What is the torque? Maximum torque transmitted by a shaft if the maximum shear stress induced to the shaft is 45 Newton per square millimeter. This is what type of stress here? It is the shear stress, that is 45 Newton per square millimeter. So the formula was derived in previous sessions, that is T equal to pi by 16 times tau d cube. That equal to pi by 16 times, what is the tau? The tau is 45 Newton per square millimeter, and the diameter of the shaft was given, that is the 150 millimeters cube. Now, after calculating, the values obtained is 29820,586 Newton millimeters. So if we convert it to Newton meter, then it becomes 2980.586 Newton meters. Still, we can simplify it. We can also convert this in terms of kilonewton meter. Then the value becomes 29.820 kilonewton meter. So this is the torque transmitted for the diameter of the shaft, that is 150 millimeters, and the maximum shear stress induced in the shaft is 45 Newton per square millimeter. So this is the 29.820 kilonewton meter, and whereas here in terms of Newton meters, that is 29820.586 Newton meters. Now this is the direct formula in this. This is the substitution directly in the formula. The formula here, it is the maximum torque transmitted by a solid circular shaft is capital T equal to pi by 16 times tau d cube. Here where the tau is the shear stress and d is the diameter of the shaft. So for the given data, we have to use this formula. And let us begin. Sometimes they ask in output parameter, the output parameter is the diameter of the shaft by giving the torque and the shear stress. Okay, in this problem, the input parameters, input data is the diameter of the shaft and the shear stress, and output is the torque transmitted. We have to find out. So let us begin. Some of the problems here, they ask the output parameter. The objective is the diameter of the shaft, and further, what is required? We know the formula, that is tau equal to T equal to pi by 16 times tau d cube. So the output parameters, the torque, and input parameters are shear stress and the diameter of the shaft. The shear stress and the diameter of the shaft are the parameter here, input parameters. Sometimes they will ask you, it depends upon the given data. Here the given data is considered as the input parameters. Alright. Now the shear stress is a solid shaft is not to exceed 40 Newton per square millimeter. The shear stress 40 Newton per square millimeter. When the torque transmitted is 20,000 Newton meters. So 20,000 Newton meters, that is the torque transmitted here, convert into Newton millimeter, that is 20,000 times 10 cube Newton millimeter. Now what to be found? Determine the minimum diameter of the shaft. What is the D that is to be found? Determine the minimum diameter of the shaft. So here we are in continuation to the torsion. That's why we can understand this problem is going to be solved by using the formula which was derived, that is tau equal to pi by 16 times tau d cube. Suppose if they are directly or cracking the question in the question paper, then how to identify it, which module this problem is related to. So that things we can identify very easily, provided if we understand all thoroughly understand the concepts of the problems, then we can locate where it is, which module, which topic, and which formula. So we have to practice more and more. The more practice means the more we can identify the location or where the this mod question is related to the module. Now here, so determine the minimum diameter of the shaft, that is t equal to pi by 16 times tau d cube. Here they are asking d cube. What is the d? So from that we can get it. That is what is the d. First, d cube equal to 16t by pi by 16t by pi tau, and d equal to 16t by tau pi power 1 by 3. So substitute here the values, the known values, the T we know torque and shear stress also know. Now 16 times the torque. That is here one more thing, 20,000 Newton meter, convert into, to maintain the dimensional homogeneity, convert this Newton meters to Newton millimeters. That is 20,000 into 10 cube, that is Newton millimeter. So 16 times 20,000 to 10 cube by tau. What is the tau value? 40 Newton per square millimeter, and the pi power 1 by 3. Then after calculation, after substitution and doing calculation, then the diameter is observed as 136.2 millimeters, the huge practically. So big is the huge diameter because the torque is high, the 20,000 Newton meters. So that is 20 kilonewton meters. So more torque. That's why, and the stress, the shearing stress is not to exceed 40 Newton per square millimeters. So for the given that is the practically here 136.2 millimeters, that means 13.62 centimeters, 13.62 centimeter diameter. So we can conceive the the diameter of the shaft, that is 13.62 millimeters. Okay. So what is the unit for torque here? The torque unit is given here Newton meters, and whereas the shear stress unit is given that Newton per square millimeter. So we have to maintain either dimensional homogeneity, as I mentioned a number of times. So further we have to either shear stress to be converted into Newton per square meter, or the torque to be should be converted into Newton millimeters. Alright, so here the main thing is that, so we converted the torque transmitted into Newton millimeters, not in Newton meters. So because the shear stress value is in terms of Newton per square millimeter. Alright, so that's why we considered here the minimum diameter of the shaft we calculated, that is capital D equal to 136.2 millimeters. All right. Now coming to the what is the torque transmitted by a hollow circular shaft. The torque transmitted by a hollow circular shaft. Here in this figure we can see the cross section of the shaft. The hollow circular is this, that is inside radius is Ri and outer radius is Ro. This is the outer radius. This is Ro. Inside inner radius is Ri, or inner diameter Di, outer diameter Do. Now, as we have solved in the case of solid circular shaft, we consider the elemental ring. In the same way, we have to consider here elemental ring at a radius of small r, and the thickness of that elemental radius, the thickness of that elemental ring is the dr. So where r naught, as we have mentioned here, r naught is outer radius of the shaft, ri inner radius of the shaft, small letters r, that is radius of elementary circular ring, dr thickness of the ring, whereas what is the tau, maximum shear stress induced at outer surface of the shaft. This tau is the shear stress induced at the outer surface of the shaft. Whereas the Q here, the shear stress induced where? At the elemental ring. So this is the Q, whereas the dA is the area of the elementary circular ring. dA is area of the elementary circular ring. dA, that dA comes area of the elementary circular ring, that is the 2 pi r times dr. So the dA equal to 2 pi r times dr. Alright. So Q is the shear stress induced on the elementary ring. Okay. And at elementary stress induced on the elementary ring, what is the radius of that elementary ring? The radius of the elementary ring here, it is small letter r, small r. Okay. Now after that, what to do? We know the ratio of the shear stress at the outer radius tau by r0 equal to Q by r. Here that is the ratio remains the same. Okay, but the shear stress is the maximum shear stress induced outer surface. What is the outer surface radius? R0. And at the elemental ring Q by R, from that Q equal to tau by capital R, R naught times small r. This is what elementary shear stress developed. Now, what is the force? What is the force equal to stress times? Yes, force equal to stress times area. So, tau. What is the Q times dA? What is the Q value here? Tau by R0 times R. What is the dA? 2 pi R dr. That is 2 pi for simplification. After simplifying, what is 2 pi by times tau by R0 and R square dr. So this is the turning moment for the turning moment of torque. This is what is the turning moment? Now turning force we calculated. The turning moment means torque equal to turning force times radius. That is the distance of the ring from center. Now again another radius. So 2 pi times tau by r0 r square dr times small r. That is 2 pi times tau by r0 r cube dr. Now this is the elemental torque. Turning force times the distance of the ring from center. The dt, torque, elemental torque on the ring. So you want a total, that means 0 to r naught. But here it is, where it is, this is a hollow circular shaft. But this hollow, what is the inner radius? Ri to r naught. Yes, that's why torque equal to, we have to integrate the dt elemental torque from Ri to R0 or R naught. Now here Ri to Ro, that is 2 pi times tau by Ro r cube dr. Now 2 pi times tau by R0, that R cube is the R power 4 by 4. Substitute R naught and Ri in that equation. In that integration, then the torque T equal to 2 pi by 2, tau pi by 2, R naught power 4 minus Ri power 4 by R naught. This is the torque, total torque in terms of radius. We need in terms of diameters, then substitute R naught equal to d naught by 2 and Ri equal to di by 2. Okay, in the above equation, then we'll get it what? The total torque of a hollow circular shaft in terms of diameters. Yes, that's what substitute. What is d naught here? Outer diameter. What is do? Not d naught. Do is outer diameter of the shaft. Di is inner diameter of the shaft. Substitute where in the place of r naught with replace r naught with d naught by 2. Ri with Ro with d naught by 2, do by 2, and Ri with di by 2. Then after simplification, we'll get it the total torque equal to, in terms of diameters, that is tau that is T equal to pi by 16 times tau times the d naught power 4 minus di power 4 by d0. The methodology is same for both the calculation of both hollow circular, solid and hollow circular shafts calculation. Yeah, what is the methodology here? We followed step 1, consider the circular shaft. Now what is the step 2? Elemental ring, where elemental ring at the radius of small r in the case of solid circular, and in the case of hollow circular it is r. For hollow circular shaft, again is the elemental ring. Alright, the elemental ring. Here also elemental ring you have to consider. And what is the thickness of the elemental ring? The dr. We consider here also r and dr. And this is ri and it is ro. So we followed the same methodology, and after finding out the elemental torque equal to elemental force times radius. What is the elemental force? Elemental stress. What is that? Elemental stress is shear stress. The shear stress, we know the shear stress equation, tau by r0 equal to q by r. From that q, what is the shear force comes? Shear stress times area, that is 2 pi r dr dA. Okay, the methodology is same, the calculation from the concepts of torque. Okay, now after substitution and we derived the formula in terms of the shear stress and outer diameters and inner diameters here, that is tau equal T equal to capital T, torque equal to pi by 16 times tau d power 4 minus di power 4 by d naught, or that is do power 4 minus di power 4 by do, where do is the outer diameter, di is inner diameter, tau is the shear stress, the maximum shear stress at the outer surface of the shaft. Now, what is the power transmitted by shaft? What is the power transmitted? Here the power transmission is nothing but here in terms of the torque is 2 pi nt by 60. So this power transmission is same. The torque maybe T is the different for solid to hollow circular shafts. So the power transmitted by the shafts here, where N is 2 pi nt by 60, where N is speed of, that is RPM, revolutions per minute of the shaft, and capital T is the mean torque transmitted in Newton meters, where omega is the angular speed of the shaft. So power P equal to 2 pi times nt by 60, that is watts. What is the T here? Okay, now 2 pi n equal to omega, that is power P equal to omega T. Now R T times omega, power P equal to, this T is the mean torque transmitted. Okay, it depends upon how the mean torque and all we calculate while solving the problems. Okay, the mean torque transmitted. Now, what is the unit for, again units for N? N is revolutions per minute, RPM, and mean torque is Newton meter. And what is the power? Power comes in terms of watts. Okay, when the speed of the shaft is in revolutions per minute and mean torque transmitted in Newton meters, then what is the angular velocity? The angular velocity 2 pi n by 60, that is radians per second. So the power P equal to T times omega. Okay, this is the power transmitted by shaft. What is again? Let us recapitulate. So in order to solve the problems by using the formula derived here, that is torque of a hollow circular shaft, that is pi by 16 times tau d naught power 4, do power 4 minus di power 4 over do. Now let us solve the problems to understand how the formula is to be applied while solving the problem such a way that we can calculate the given objectives. Now here in your hollow circular shaft of outer and inner diameters of 20 centimeters and 10 centimeters. Outer and inner diameters of 20 centimeters and 10 centimeters. The shear stress is not to exceed 40 Newton per square millimeter. Find the maximum torque which the shaft can safely transmit. We want maximum torque here, but they already gave directly mentioned it is a hollow circular shaft. Yeah, while solving the problems in examination, how can we identify which module, which it is, what type of is this this problem related to variation of bending stresses, or variation of the shear stresses, or bulk modulus, or deflection of the beams, or simple stress and strains, or shear force and bending moment diagrams. Where is the location? How can we identify it? So the problem can be identified, or location can be identified by using the given data. So the data was given here: hollow circular shaft, and outer and inner diameters are given, and the shear stress given. So shear stress was given. The value of the shear stress is given as 14 Newton per square millimeter. So what to be found? We have to find out the maximum torque. So that means it is related to the torsion module, torsion topic, the maximum torque which the shaft can safely transmit. Now we know the direct substitution, very simple. There is no conceptual orientation of asking questions. Now what is the direct? That is the T naught equal T torque equal to pi by 16 times tau do power 4 minus di power 4 by do. What is the T here? T is the shear stress. What is the shear stress value given here? 14 Newton per square millimeters. The shear stress is not to exceed, is not to cross over. That means it is that one. This is the limitation of the shear stress that was given here. It is as 14 Newton per square millimeters. And one more thing, here the hollow circular shaft. Yes, this is related to hollow circular shaft. And the outer and inner diameters, outer diameter is 20 and inner diameter is 10, half of that one. So diameters are given, converted into millimeters to maintain dimensional homogeneity. That is outer diameter d naught equal to 20 centimeters, that is 200 millimeters in terms of millimeters. In the same manner, the inner diameter di is 10 centimeters, that is 100 millimeters. The maximum shear stress tau equal to 14 Newton per square millimeter. Now, pi by 16 times tau 14 do. What is the do value? 200 millimeters power 4 minus di power 4. What is the value of the di? 100 millimeters by do. What is the do? 200 millimeters. Yeah, substitution. Substitution, and after the calculation, the obtained value here it is, in terms of Newton millimeter, 58904.860 Newton millimeters. So to get significance, convert into in terms of Newton meters, that is, it becomes by 1000, then 58904.86, that is Newton meters. This is the torque transmitted. The torque transmitted. Alright, here in this manner we have to solve, we have to apply the derivable formula for the given data to obtain the maximum torque value. Okay, now next here, if we consider some of the problems, yeah, very important here. Let us understand this model is so important model, very important. The topic of the torsion. Two shafts of the same material, and of same length are subjected to the same torque. If the first shaft is of a solid circular section, yeah, first shaft is the solid circular, and the second shaft is what? Hollow circular section. And the material is the same material and same length. L is remains same, material remains same, whose internal diameter di is two-third of outer diameter, and the maximum stress developed in each shaft is the same. And compare the weights of the shafts. So here, what are the things are given? That it is the same material, same length, and also same stress developed, because the material same, the maximum shear stress developed in each shaft is also same. We want to compare both the weights of the shaft. We have to compare both the weights of the shaft. How to do it? Let us discuss this type of problems orally more, then we can go for solving the problems. Okay. Now, we have solved in these problems that okay, in this we have derived a hollow circular shaft. What is the torque transmitted there for a hollow circular shaft? That is T equal to pi by 16 times tau d power 4 d naught power 4 minus do power 4 minus di power 4 by outer side diameter do. And one more thing, the previous sessions we have covered what is the maximum for a torque transmitted by a solid circular shaft. That is tau equal capital T equal to pi by 16 times tau d cube. Now here the inner diameter of the shaft, that is the inner diameter di equal to 2/3 times do. There is only one condition. Alright. So what is wet? Let us assume that what is parameter Ws is the weight of solid shaft, Wh is the weight of hollow shaft, and length of each shaft, and small w is the weight density of material of each shaft. Now, so simple. First, solid circular shaft torque equation, that is T capital T equal to pi by 16 times d cube. Here d is the diameter of solid circular shaft, and we have derived just now the hollow torque transmitted by a hollow circular shaft. What is the torque transmitted by a hollow circular shaft formula? That is capital T equal to pi by 16 times tau d naught power 4 minus di power 4 by d naught. That is pi by 16 times tau d naught power 4. What is the di? What is the di equal to? That is 2/3 times d naught. Substitute here di value here in the place of on the place of d, substitute the value of the d, that is 2/3 times d naught. But then again d naught. Then simplification, after doing simply, that is pi by 16 times tau d naught power 4. This is 2 power 4, that is 16, and 3 power 4, 18. 16 by 81, d naught power 4 by d naught. So there is a common here factor. If we carefully observe here, that equal to what will happen here, that is pi by 16 times. If you make it subtraction from this 81 LCM, 81 d naught power 4 minus 16 d power 4, then what will this is 65 d naught power 4 by 61. This is pi by 16. Alright, that is tau equal to pi by 16. Pi by 16 times tau 65 by 81 d naught power 4 by d naught. This d naught in d power 4 get cancelled, that is d naught cube. That's capital T equal to pi by 16 times tau 65 d naught cube by 81. This is the equation. Now that is equation 2. So if you carefully observe, the torque transmitted by the solid and hollow circular shafts are same, because they mention here it is having the same material, okay, same shear stress developed, that means torque is same. So equate equation 1 and 2, that is tau equal to pi by 16 times d cube. This is the d naught. Now cancelling the pi by 16 tau both sides, then d naught to d cube equal to 65 by 81 d naught cube, and d equal to 65 by 81 d naught cube power 1 by 3. Then if you understand that equal to d equal to, we got the value d equal to 0.929 d naught. This is the relation, we got it here. Alright, 0.929 d naught. Okay. Now we want weight of the shafts. Now second part, what is the weight ratio? We found just now the relation between d of the solid circular shaft and outer diameter of hollow circular shaft. That's the relation. Now here, how to find out the weight of the solid shaft? Weight, that is weight of the solid shaft equal to weight density weight density, Newton per cubic meter times volume of the solid shaft. That is W times area. What is the volume? Area of cross section times length. That's W times pi d square by 4 times L. What is the hollow circular shaft? Again, W times area of cross section of hollow shaft times L. Now W by times area of the cross section of the hollow. What is the area of cross section? Pi by 4 times d naught square minus d square by times L. Here substitute what is the d naught, d and d naught. Now that di, yes, as you mentioned here, just now we calculated that di equal to how much value? 2/3 times of d naught. That was given. Then after simplification, we'll get finally WH equal to W times pi by 4, 5 by 9 d naught square times L. This is the equation 5. And this is WS. Now we want weight ratios WS by WH. Equation 4 by equation 5. That is cancelled. WW pi by 4, pi by 4, L. That means it happened 9 d square by 5 d naught square. Now that is WS by WH. 9d square by 5 d naught square. Now we already found what is the d value. The d equal to 0.929 times d naught. Substitute here in the place of d with this value 0.929 times d naught. Then after simplification, we'll get the ratio, that is 1.55. Weight of solid shaft 2 and weight of hollow shaft is 1.55. So that means weight of solid shaft is higher, how much? 1.5 times higher than weight of hollow shaft. Alright. So that's why solid shaft weight is more than the hollow shaft. That is more than how much here? 155%. So more than the self weight, that is 55% more. Now that is the here the ratio of weight of solid shaft to and weight of hollow shaft. Now here, all right. In this session we covered and here in this session, let me summarize. We solved the problems of torque, maximum torque transmitted by a solid circular shaft. Then we derived a formula of torque of a hollow circular shaft, and we solved the few problems on hollow circular shaft. And finally, unique model we solved what is the weight ratio of the solid to hollow. So based on the maximum torque equations, and we found the ratio of the weight of the solid shaft to weight of hollow shaft, that is 1.55. Okay, this is important, very important model of this problem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.